Okay, so good evening, everyone. This is Samarth, and today we'll be continuing our topic that we did yesterday, that is limits, continuity, and differentiability. So, starting with absolute value. So, what do we know that absolute value of a real number x is denoted by like long straight lines and is defined as this. So, there are some properties of absolute values that we can see. So, if absolute value of x is zero, then x is zero, and conversely, okay, if x is not equal to zero, then the absolute value of x is always greater than zero. This is true. This is also true. Okay, so let's do some special symbols. This is also very understandable. What do you mean by maximum of a comma b? So that is easily understandable. Okay, so yeah, doing the graph, this is important. So this is often done in given in JEE as well, that you have to plot the graph of maximum of x, f of x and g of x. So here what can be done is that we plot f of x and g of x and try to see that how these graphs move when we are going from we are how we're moving in the domain of x. So you can see here if we plot f of x and g of x, for example, that f of x is like this and g of x is like this. So you can see the maximum goes like this and the minimum goes like this. So you'll have to do your analysis according to the question provided. So okay. So this is okay. Now talking about limits as the our topic of discussion is today. So the limit, we have to find the limit of the function, right? At two. So this is very easily can be done. So you can see that if we put x is equals to 2 in the function, like f of x is equals to 2 gives us f goes to infinity or not defined, since we are dividing the whole function by 0, since division by 0. So that is not allowed, right? So we'll try to find the limit of it. Why we have to find the limit of it? Because it is not defined that it is equal to 0. So we'll try to find the limit of it. What do we mean by limit? So by limit, what we mean is that we find value of f of x plus delta x and f of x minus delta x. And in most cases, these values converge, right? These values converge to a single point, and that is the limit of the function. So let's see what is the outcome. So let's try calculating the value of x at 1.9, 1.99, and somewhat like this. So this is the values that you observe, right? See, you can see the graph of this function as well. So what does the graph look like? There is a dot here. This dot represents that x is not f of x is not defined at x is equals to 2. But in seeing the values, we can see that at x is equals to 1.999, we get a value of 3.999, and similarly at the value of 2.001, we get a value of 4.001. So what we can say here is that our f of x is equals to 2 converges to 2. We can also see that mathematically that f of x is given to us as x square minus, let me just make it a bit bolder. Yes. So it is given to us x square minus 4 upon x minus 2. So we can do is x minus 2, x plus 2, and x minus 2. So we can cancel them out for the time being, and we get x plus 2 as a function. And at x is equals to 2, it is 2 plus 2, which is 4. So the limit of the function at x is equals to 2 becomes 4. Okay, so these are similar functions, right? If we cancel out x minus 2, so we get a new function that is x plus 2. And it is what g of x actually is. Okay, so let's move to a different question now. So what is given to us? Limit of the function h of x is equals to this upon my x, right? So what we can do here is, so we know it is like this, it is mod of x, and now we're multiplying x to it. So we are dividing x to it, right? So let's divide. let's divide what the function would look like at different values. So h of x for x greater than equal to 0 is 1, and x less than 0 is minus 1. It's as simple as that. So we get this and this, right? Let's see how does that work. It is not defined because we do not have a value of x is equal to 0. So we'll put a circle here and a circle here. Hollow circle, not a full circle. See, as we did earlier, the limit of a function is this. uh, that we find the value of x at less than the number that we have to find the limit at, and a bit higher than the number we have to find it. And if those are not equal, then the limit does not exist. In the previous case, we had a equation where x of 2 sorry, f of 2 plus was equals to f of 2 minus, and by plus and minus what it means is a value greater than 2 or a value less than 2 with a small deviation like 2.001 and 1.99, and they both were converging somewhat equal. So that is why we can say the limit existed there. But here there is no limit since f of 0 positive, 0 plus and f of 0 minus was not equal, but not equal. Okay, so let f of x be a function of a real variable x, the symbol. Okay. Yeah, this is like a symbolic representation. What do we mean by tens? And this you might be aware. If you've studied the limits for JEE a bit, you must have done these questions and you might understand what do you mean by this. Okay, so right and left hand you might be aware of, but I'll just recap it. So by right hand, what we mean is a positive, like right hand. So we move in the graph like this, right? So this is positive and this is negative. So as we move here, the values increases, right? As we are moving this, values increase. That is, if this is A1 and this is A2, so A1 is greater than A2 in the standard case, right? So that is why we take this as a right hand case, because as we move towards the right, we're moving right here, right? So our value is increasing, so it is A positive. And similarly for left hand, as we move to the left, the value of A keeps decreasing, so it is A minus value. Okay, so let's see the what do we mean by limit of a function. Let's go by a definition for a minute. So what we mean is if a function f of x possesses a limit at x is equals to a, that is a limit of x is equals to a, fx is equals to L exists, then this limit is independent of the fashion that x tends to A. Whether x tends to A from right hand side or from left hand side, the two limit obtained must be the same. Hence, in the order that limit x tends to A, f of x is equals to L, exists the two limits. Limit x tends to a positive fx and limit x tends to a negative fx must be equal, and they both must exist first of all. So yeah, it is pretty understandable as I said earlier. Okay, the concept of limit is illustrated by the following diagrams. Okay, so f of exists. Okay, ठीक है, we know that at positive, no, at positive we know that it exists. At negative it does not exist because it's tending to infinity. It's going to infinity, so the limit does not exist. Okay, next. Okay, so here we can see there is a limit here, there is a limit here, but those are not equal, so we do not have a standard limit. Let's go to another question. So what we have here is that, okay, so yeah, we can see there is an easy limit here. If we have to find a limit here, so both of the limits, like a positive limit and a negative limit, are converging to this point. So there is a limit existing here. Okay. So the next question, we can easily see that here it is tending to infinity, but this is going to zero. Those are not equal and it does not exist, so limit does not exist. Here we can see the limit exists because even though the function is not defined at x is equals to 0, you can see there is a hollow circle here, but the function is not defined here, but we can see a hollow circle at x. is equals to 0. But we can see that the function is converging here. So we can say the limit exists, even though there is not a defined value of x of f at x is equal to 0. Okay, here it does not exist because there is a different value altogether. Here the limit exists because they both are converging to this point. Some people might say that it is not smooth and it is like a point, like a sharp edge here. But then too, since the sharp edge is converging to a same point, the limit will exist. Okay, here the limit does not exist because these both are going to infinity. One would say that why not? These both points are going to infinity, so they are equal. But these are going to infinity, and infinity is not defined in mathematics. So we can say that it is not, limit is not existing here. Yeah, here limit exists. What kind of graph is this? Can somebody like tell me what kind of a graph this is? So it is a mirror image graph, right? Or is it not? It is a mirror image graph, so it gives me similarity to x sin x. If someone has seen x sin x graph, it is very similar to this. But it is not a mirror image, so there might be some signs or a absolute value that they must be. But it is very similar to x sin x graph. Let's see another question. So infinity in symbol, we write x, limit x tends to f of x is equal to plus infinity or ठीक है. This is very easily understandable. See, infinity is very, we cannot play mathematics with infinity because mathematical operations are not applicable on infinity. So see, it is given here infinity plus infinity is to infinity. It does not happen. So what do you mean by this infinity and this infinity and how are they equal? We cannot say two infinities are equal because infinity is not parameterized, right? We don't have value for infinity, so their mathematical applications or numerations are not applicable. That is why we don't do any applications on it. Anything done with infinity would give you infinity and something which are not defined. For example, their addition would give you infinity, their multiplication would give you infinity, but subtraction does not is not defined. Division is also not defined. Okay, so let's see some examples and some limits where the limits are going to infinity. You can easily see it is going to infinity. This is also infinity. This is going to minus infinity. This is going to This should also go to minus infinity, guys. What is the issue here? This is going to infinity, but I didn't get this part. Okay, so let's stick with this example. Okay, so you can see it's very easy. Let's do some questions if possible. So we have done this, right? We did this. Okay. Here they have said that it does not exist, but we just calculated this, right? So because x is okay, so there's a difference here. It's an absolute value, but here it is not absolute. So log does not take negative values, right? So x cannot go to O0 because O0 would be less than 0. And that means negative, so it does not exist. Let's see something other example that we have. A function of f of x is said to be continuous at x is equals to a. If f of x is well defined at x is equals to a, okay. The continuity, yeah. So coming to continuity, continuity is a very simple. It's not that complicated of a concept. So by continuity, what do you mean? If we have to check if a function is continuous at a point, so what first thing we do is their limit should exist at both points. If we are asked about continuity, at point t naught, right? So first of all, what we do is we check the continuity at we first of all check the limit at x is equals to t. So first of all, what we do is we try to calculate the limit at x is equals to t naught, and if it exists, half of our job is done. But there is another condition that has to be satisfied. This should be equal to f of t naught. If a function is continuous at this continuous, there are two conditions that has to be satisfied. That is, the limit should exist at x is equals to t naught, and the function that should be equal to the value defined at is equals to t naught. Okay, just a minute. I'll have to like. Okay, so let's talk about continuity of a function. So type of intervals we have, what intervals we have. Let me see. So just a minute. Yeah. So the continuity of a function, as said, the closed interval A is B is the collection of all real numbers. So that we had done this in the previous class. This is also right. This is also right type of intervals. This is also done. So there are five types of continuity, as one is saying that f of x is continuous at a and b. We can see that this because there is no breakage in the function, and it is completely defined here. It is defined at open here because we have taken open here because at a and b f of x is going to infinity. So we have to take open brackets here. It is also defined, it is continuous here because at open a to open infinity, because here it is going to infinity here. It is continuous at from minus infinity to here because closed, why we have taken a closed continuity here, because there is a limit existing here. It is continuous from this point, and the function has been defined here. So limit of x a minus is equals to f of x is equals to a. So this satisfies our definition of continuity here. So that is why we say that the function is continuous at this point. This is continuous for the whole real line. Okay, so a function is said to be discontinuous if it is not continuous. Okay, fine. So this is discontinuous. Of course, it is discontinuous. This is discontinuous. This is discontinuous. Because it is not defined at here, a, right? A function f of x is differentiable at x is equals to x naught if the left hand derivative and the right hand derivative both exist and equal. Geometrically, the left hand tangent and the right hand tangent have the same line. It is very understandable. So first example that pops into my mind is absolute graph. So do we is the function differentiable at x is equal to 0? It is not, because the tangent and the length of the the we see the slope, yeah, slope. The slope of the line and the tangent are both equal. So let me raise it and make it a fresh graph. So it is this, right? So here the slope is 1, here the slope is minus 1. And these are not equal at x is equals to 0, right? So that is why it is not continuous at x is equal to 0. For example, here as well, it is not continuous because the slopes are different. Here the slope is equal, so it is differentiable. Here the function is not differentiable since the tangent has a vertical slope. So whenever the slope is infinity, right? If yeah, when the slope is infinity, it's infinity, right? It is a y is equals to 0 line. It is x is equal to 0 line. So yeah, when the slope is 0, the slope is 0 is x line, yeah. So yeah, if the slope goes to infinity, then the function is not differentiable. Let's move on to further differentiability. So I think I just said that what is Yeah, so let's talk about more about differentiability and the different rules that we have for differentiation. So, if the a bit of mathematics. So, what differentiation usually looks like? So, we can say f dash of x is equal to f of delta x, pl- sorry, minus f of x upon delta x. Limit delta x tends to 0. It is an important definition of differentiation that is usually used in limits and continuity chapters. So again, I'll pair it out for you. F, okay, let me write it properly. F of x is equals to limit delta x tends to 0, f of x plus delta x minus f of x upon delta x. I hope it's clear. It's an important definition. Okay. So let's see product and quotient rule. So let's consider the function x is equals to 6. What is the derivative? We rewrite it as a product of x square and x to the power 4. Now what is the derivative? So as the popular belief, someone with no knowledge of differentiation might believe that this is the how differentiation works, but this is wrong. In differentiation, there is something called as product rule, and we'll soon learn what the product rule is. And when two functions, like for example, see f of x is given to us, h of x and g of x. So f dash of x is not equal to g dash of x into h dash of x. This is completely wrong. It is not the case. We have a product rule in place that we use and to find solution. So what is the product rule? The product rule is this. I'll highlight it for you guys. See, I'm using the highlighter now. So this is the product rule that you have to use, right? So let's see how we can apply it. Yeah. Let's go to the first example. Let's not see the solution first and try to do it by ourselves. The comparatively easy question. What we have is we have f of x is equal to 3x squared dot multiplied by e to the power x. So let's see how we differentiate it. Okay. So let's write f dash of x is equals to g of x into h of x, where g of x is equals to 3x square and h of x is equal to e to the power x. And fine. So as the f dash of x would be equal to g of x into h dash of x plus h of x into g dash of x. So let's write it. So h of g of x is 3x squared. Then differentiation of h of x is then h of x as it is, and the differentiation this. So what we get is e to the power x common 6x into 3x squared. Okay, my bad. So these are some examples, right? Okay, fine, not my bad. So these are the example of the functions where the product rule will take place. So what we did is we take this as a different function, this is a different function, and apply the differentiation rule, product rule. Similarly, this is a different function here, this is a different function. Here, here also you can take this as a different function and this is a different function. Here is a different function and 1 by y cube is a different function. But someone would say, sir, that it is not this is not multiplication like e to the power x into 1 by y cube is also can be interpreted as e to the power x divided by y cube. So there should be a division or quotient rule as well, right, for differentiation. So yes, there is a differentiation quotient rule that we have in place. And yeah, so there is a very similar rule. And we can also like, yeah, since we know that we can derive the rule from here as well. So let's see how the quotient rule derives from the product rule. So let's see. So we have the formula here, the quotient rule, and the derivative form of it. This you guys can learn. It's very simple. What we have is we take the denominator first, then then calculate the derivative of the numerator subtracted by numerator derivative of the denominator and the whole square of the denominator. It's very easy. Okay, so these are some examples. Okay, so we did this, right? Let's see some new concepts that if we can see here. So yeah, some difference rule is very simple. What we do is if a y of x is given to us as f of x plus g of x, and we have to find the derivative of y of x, it's simply derivative of y of x plus 1 is derivative of g of x. Product rule we just saw, quotient rule we just saw. Yeah, the chain rule. The chain rule is very important, guys. It can like it's a lifesaver for you. So what we do here is if y is a function of v and v is a function of x. So what we do here is that if we have to derive we have to derive the function of y with respect to x. What we do is we can derive the function of y with respect to v first, and then derive the function of multiplied by the derivative of v with respect to x, as the formula states here, right? This is a very important rule, and has a various amount of applications. For example, yeah. So if you can see the example here, I don't think I'll have to write here. So if this is the function that is given to us, so let's take v is equals to this. So what are we left with? This. So it is very simple to the theory that we did is that if v is a function of x, which it is, and y becomes a function of v. So let's derive first y with respect to v. So what we get is half v to the power minus half. We write it as it is, and then we put the derivative of v with respect to x. So what we get is 2ax plus b. That satisfies our equation, right? And the chain rule that we did. So it is very important to learn this chain rule. Again, we take the inner part as v and then solves the complete equation. So the inverse function rule is also very important. Yeah, so the inverse function is also very important. So more than like it's a bit of a rare case where x is given as a function of y and we have to derive it. So we know that dy by dx is equals to 1 upon dx by dy. This is a rule that you can easily remember. It's just simply taking an inverse of it. For example, it is given to us x is equals to 3y squared. So if we have to find dx by dy, so what we get is 6y. Then dy by dx is equals to 1 by 6y. As simple as that. There is no complications there. You can just simply take an inverse of it. So of course, differentiation has various applications, and one of those is economics. But since we are not related to economics or we are science students, so we might have less contact to it. So let's move on. So yeah, differentiation is very easy of exponentials also. You know, right? That sorry, differentiation of e to the power x is always e to the power x. There is nothing that changes here. That we know the graph of e to the power x, right? It is this. And if we take the slope of it at each point, what we observe is that it is same as the original graph. So e to the power x has its own graph as its derivation. So sorry, as its differentiation. So we can see that it is the same. So moving on, natural log of differentiation we have to see. So these are really important concepts that you should learn. Not concepts, but basically these are formulae that you should keep them by your heart. So this is also very important that if y is equals to ln x, then dy by dx has to be 1 by y. and it can be equally derived from this itself, right? This is the important formula that I talked about. Okay, so let's move on to the next part. Right. Okay, so this is also important. Like most of you might not understand that how is it is working. So if we have writing ln of mx, and those of you have might have done log earlier, so this can be written as log of m plus log of x. And since m is a number or a coefficient, it would become a constant, right? And differentiating a constant number simply gives you zero. So it's like a direct rule. It's not something out of the world, but you have to remember this. If you remember directly, you'll get a easier way of solving questions. Yeah, it's very easy. This is also easy. We're applying product rule and this. Let's not go here. It is not required. It is also not required. Not required. Not required. Yeah, we can do this probably. No. Let's see some questions, right? Let's see some questions. So the first question that we have is, it is given to us ln of x plus y is equals to 4xy. And we have to find the derivative dy by dx square at x is equal to 0. It's simple. Let's start let's start with the chain rule, and let's start the question by differentiating the whole equation by x by d of x. So the differentiation of ln of x plus y is, first we take the chain rule and write it like this. Then the differentiation of x with respect to dx is 1. Then we get is dy by dx. This is equals to 4y plus 4x dy by dx. As simple as that. Then again we put a differentiation or what? Okay, so what are we doing here is we are finding the value of dy by dx at x is equals to 0. So let's see. The value of it x is equals to 0. First we'll have to calculate value of y, right? So at x is equals to 0, what we get is ln of y is equals to 0. So y is equals to 1. Now putting these two values here to get the value of dy by dx at x is equal to 0. So what we get is 1 by 1 upon dy by dx is equals to 4 plus 0. So dy by dx turns out to be 3. This value we have to remember. So both values that we calculated are important. That dy by dx at x is equals to 0 is 3 and y at x equals to 3 is 1. Okay, so now again let's differentiate. What equation are we differentiating? This equation. So let me erase the rest of the part. Array. Okay, so let's differentiate. Let's take x, y there and then differentiate. It would make our life easier. So let's take x, y there. And what we have here is 1 plus dy by dx. So differentiation of 1 is 0. Then dy dx square is equals to. So we have this a whole dy by dx into 4y plus 4x dy by dx. So let's do this first. So what we have here is, let's apply the product rule that we learned here earlier. So what we are differentiating this first. So it is 1 dy by dx, then multiplied by 4y plus 4x dy by dx plus x plus y into 4 dy by dx plus again product rule 4x dy x square plus 4 dy by dx, right? So this is the whole equation, and now let's start putting values. We have to find dy by dx square. So 1 plus 3 into 4. This is going to 0. This is going to 0. It's very easy now. Let's say this 4 plus 1, 1. 4 into 3 and 4 into 3. Okay. This is 16 plus 4 into 6 is 24. So am I getting a value of 40? Am I correct or wrong? Let me see. I am correct. So we have a value of 40. It's a very easy question. What we did here was we simply differentiated the whole equation and tried putting values of I and dy by dx, not in the first step, but in the last step. So that made the question very easier for us. Let's see another question. So P is a point on parabola x square plus 4, which is closest to the straight line y is equals to 4x minus 1. The coordinates of P are. So what are we getting at? X is equal to 0, y is 4. And the minimum, so it is this. This is the function that we have. And what is the straight line? The straight line is y is equals to 4x minus 1. So at x is equals to 0, we have y is equals to minus 1 and the slope is positive. So I don't think they will converge. Will they converge? Let's see. Okay. So when we talk about the closest point, so we can see that the slope of these both points has to be same. If this is the point, for example, if this is the point, then there would be a line with the same slope, right? Passing through this. So let's see if we can find a line which has the slope 4. So dy by dx is equals to 2x. So 2x has to be 4, so x gives me 2. So the point we have, so at x is equals to 2, y becomes 2 square plus 4, and that is 8. The point becomes 2 comma 8. But it is giving me minus 2? No. So the point which is closest to the parabola, on the parabola to the line is 2 comma 8. And how do we calculate is that the slope of the parabola at this point will be equal to the slope of the plane, slope of the line, right? That is why D is our answer. Now another question we have is dy by dx is equals to ln of x and log of a by x. So if for this guys, I think you should have a good decent knowledge of like logs because I am very thorough with my logs, right? Log of a. It's as simple as that. So we can write it's a property log of q with the base of p can be written as log, or we can take any base here. Log of a into log of q with base a and log of p with base a. So here we have taken our base as ln because that makes our like base as e because that makes our calculation very easier. So it gives us dy by dx into ln of x ka whole square upon ln of a. So ln of a is constant here, so we'll take it out. Ln of a is constant. And now what are we left with is ln of d of dx by ln of x star whole square. And then on the derivation, what we get is, so we'll apply the chain rule here. We'll take ln of x is equals to t. So we'll do the derivative of t square. We get as 2t, so 2 of ln x. And then derivation of ln x is 1 by x. So what we get is 2 ln x upon x ln a. And this can be again written as 2 by x log of base a x, right? So this is the answer that we have, and so my solution is correct. So guys, like sometimes the questions can have like a bunch of concepts that are applied together, not always. But see here, we applied two concepts together that we had to know some equations and like theorems of log as well to solve this question. Let's do this one. This is also looking nice. So what we have is हमारे पास एक curve है y is equals to yx and the function be the solution of the differentiation equation y dy by dx is equals to 2. Okay, we know differentiation of it. The numerical value of the area bounded by the curve y is equals to yx. Uh, Y is equals to yx and the x-axis is 4 root 8 by 3. The value of y is equals to 1 is equals to. Okay, so what we can see here is the numerical value of the area bounded by the curve y is equals to bounded by the curve y is equals to yx and the axis is 4 root 3. Yeah, simple. So what we can do is, so we have, let's hide the brand name here first. So let's go. So we have dy by dx is equals to 2 into x plus 1. And on let's integrate here a bit. If you're not aware with integration, it's very simple. And if you are, I mean, you might be preparing, so you might be aware of integration. So let's take dx. That's why, and do the integration. So we have integration of 2x plus 1 dx and then integrated. So we get y is equals to 2x integration is x squared, 2's integration is 2x. And let's put a constant here because we are not aware of the complete equation right now. So taking this, we can plot a graph here. We get the graph. Okay, so the area of the rectangle they have calculated, but I don't think that's necessary. We can simply calculate the area by the graph. I think what the area they have taken into consideration is this. So let's see if we calculate the area here. So again, area calculation would require you integration. So I'm not aware that if you know integration or not. So let's do the integration first. So first, let's see what are the roots of the equation, right? We will require the zeros of the equation, and the zeros would be. This is a bit complicated. I don't know why am I getting a bit complicated solution. So let's skip this question because here we have different applications taking place. We have area of the parabola and x-axis and the area of rectangle, which they're using a formula of. So let's skip this. This is not completely in our domain right now, the differentiation part of it. So let's skip this and move on to something that is a bit related to our topic today. So let's do this one. If it is given y is equals to x log x upon a plus bx, and we have to calculate x cube dy by d square dx square, like double derivative of y, right? So let's simply go with the question. Dy by dx is equals to x as it is. So let's put x as it is, then differentiate log. So it gives us x, a plus bx, then differentiating this. Okay, it's going to be lengthy now. Yeah, okay. I got the method. I have to like cheat a bit, but why not? So we get y by x is equals to log of x, a plus bx. So on differentiating, what we get is x dy by dx plus y upon my x square. And then on differentiation, we get x a plus bx. Arey yaar, sorry, I'm really uh, messing this up, but it's cool. So what we can do here is y by x is equals to log of x minus log of a plus bx. See, I told you log is very important, guys. Learning log can make your life very easy. So x dy by dx, we are differentiating, right? X dy by dx plus y upon my x square gives you 1 by x minus 1 by a plus bx into b. Okay. So now what we are trying to do is we are trying, yeah, so we'll try to shift our x square that way. So we get, okay, so I've been told that I have to end the session earlier. So let's end it by this question. So what we get is x plus x into dy by dx plus y is equals to x plus bx square upon a plus bx. And now by differentiating again, so let's take a common factor here. So we get ax plus bx square plus bx square upon my a plus bx square. So this is the equation, and you can see the solution, guys. I think it's more easier, and we can different by differentiating, we'll get a value here. Okay, do we have a smaller question that we can go by right now? I don't think so. This is very easy. If you want to do this question, we can do this. But here you'll have to see the differentiation of tan sec here. Also, I can like give you the formulas that are here right now. Dy by dx of sin x is equals to cos x, but dy by dx of cos x is equals to minus sin x. These are some differentiations that you can learn and simplify them over the internet. And these can help you a lot in the future, the trigonometric functions differentiation. So I think, yeah, we can end the session now. I suppose I am not supposed to open this. Yes, so let me end the session here.